Okay, we just answered some really good questions about what all this might mean, but we'll get to that. And I gave some answers in terms of different multivariable models, but we'll see some of those models. Okay, so just looking at what we have here, well, what we're going to write down is almost exactly what we would write down here. Okay? So this would be the limit as delta y goes to 0 of x squared times y plus delta y cubed minus x squared y cubed over delta y. Okay? Now, x squared doesn't change, so we could actually just pull that out. And then it's x squared times the limit as delta y goes to 0 of y plus delta y cubed minus y cubed over delta y, which we already worked out. Okay? So that's what? X squared multiplied by, what did we get? 3y squared, yeah, because when we do the binomial expansion of this, we get a 3y squared delta y. And then everything else we get, well, we get a y cubed, which disappears because of this. And then everything else we get has a delta y squared or a delta y cubed on it. So when a delta y squared or a delta y cubed is divided by delta y, and then delta y approaches 0, those terms approach 0. So we're just left with a 3y squared delta y over delta y, which is just 3y squared. Okay? And it isn't 12, it's 3xy squared. It was 12 before because 3x squared y squared. When x was 2, naturally that gave us 12y squared. So that's why we got 12y squared before. Okay? Now, the process of taking the partial derivative probably won't surprise you too much. We're keeping x constant and taking the rate of change with respect to y. Okay? And they're very easy parallels that you can work out rigorously. But to do the partial with respect to y of x squared y cubed, I won't say hold, we're holding x constant. We treat x as a constant and take the derivative with respect to y. Well, if we treat x as a constant, then this just becomes, well, the constant comes outside of the derivative, and we get this. And that's actually just the derivative of y cubed with respect to y in this case. So should have written a d instead of a partial. But so there it is. It has to be because this is the definition of the derivative, and you can see because of this that that's the way it has to be, if you think a little bit about it. Okay? Now, I haven't elucidated every detail because this is an applied calculus course, not a theoretical. But there's enough theory in this that you see, I think, everything you need to see. And, you know, just by getting a little more rigorous, you prove this, okay? But this is what happens. So this is how you take partial derivatives, okay?